All right, so now we're going back to those student arguments for part C. So we need to reference this equation. If you haven't read the question yet, pause it now, go back and read it. But we're supporting or refuting each aspect of the student's reasoning using only our equation. So let's go ahead with, we'll start with number 3 because I thought that was the most outrageous. Unit 3. The reason why we can refute this is because if you look at capital D, the total distance, and the acceleration is in the denominator. So if we change this, if we make this bigger, what's going to happen to this total distance? It's going to get smaller, right? So these two are not proportional to each other. They don't have a positive relationship. It's an inverse relationship. So because A is in the denominator, and I'm going to really denominator. More A, less D. All right. Number, I don't care. Number 2? Sure. So this one was talking about D and T having a relationship. So T is in the numerator, right? Because this is all assumed to be over 1. Oops, and then I erased it. So that means that as more time goes on, then yes, your distance is going to increase. So write this out entirely if this were a real problem that you were solving. I'm obviously going to truncate it quite a bit. So T is in numerator. And I think if I were to go back and try to reread this, I probably wouldn't understand what I was saying. So as time increases, then the total distance would also increase, right? If we change this, then this is going to obviously get bigger. And then the last one is talking about initial velocity and its relationship to D. Well, it's also in the numerator here too, right? So V naught is in numerator. So the more starting velocity, then the more distance you would travel to stop. Sorry, so sloppy. You'll just have to read it. Part 2. For this part, support or refute using only the graphs in part 2. So you're going to have to go back to your graphs and take a look at that. And we should know that those were velocity versus time graphs, right? And the total distance traveled is the area under the curve for a velocity versus time graph. V versus T graph. So we know that in graph 1, if we look at it again, there is definitely more area than 0. So more starting speed, you're going to get the greater the distance. More V naught, more V, more D. Number 2, graph 2 has more area than 0. So more T, more distance. And then graph 3 has less area than 0. So more A, less distance. Which obviously makes sense because you have a good handle on acceleration. Now, Mr. Scapetus, this is great. Outstanding. I'm ready for the test, right? No, probably not. You have to do this practice on your own. You have to try on your own. But let's play a hypothetical situation. Let's say you completely freak out and you blank on the test, either on the AP exam or on my test or whatever. And you never got part A. Does that mean you can't answer this? No. First of all, you could skip right on down to 2 and look at this. This is using the graphs, which whenever you are given a graph, please make sure you answer it as best you can, because normally graphs are a little bit easier. and all the information is right there for you, right? So we can come up with which one is the bigger area just by looking at it. We don't even have to do any math on that. But let's say we didn't get part A, or we got part A wrong, which is possible. Hey, nobody is perfect, right? So let's say we came up with this equation where capital D equals V naught times T. And we totally disregarded that actual stopping distance. We just used the regular formula. Not good. Not good at all. But what you can do is you can go through each one of these. So we said A is in the denominator, so more A, less D. Well, there's no reference to acceleration here, right? So hopefully that would be a clue of, oh no, I don't have acceleration. So we can't really do anything with that because it's talking about the relationship. Acceleration is what gives objects motion, which therefore big D increases as A increases. So you would presumably come up with something there. Something good, I'm sure. For number 2, we're talking about the relationship between D and T. Well, guess what? We can still get this point right here. So as T increases, so does D. Right? That's the relationship. And then for number 1, as V naught increases, so does D. Right? Those are the same exact responses. And you could say it's a linear relationship, it's a proportional relationship, whatever word you want to use. Not that linear and proportional are the same thing, right? Proportional goes through the origin, whereas linear can start anywhere. You can have a y-intercept of anything. So here, I would assume this is going to be a 3-point question for CI. Well, we just got 2 out of the 3. If you can get 60% on this, 60% of every single question, then you are well on your way to a 4 or 5. That's it. Okay. Ideally, I want you to be able to answer everything, but at the same time, be comfortable. If you mess something up, there is room within that same exact test for you to get those extra points and bring your grade up. Because that's what it's about. It's not about answering every single question exactly correctly. That's the dream. I have not seen it. I've got kids up there who are extremely brilliant. I don't believe any of them got a perfect score because I never got word of that. Okay, it's just not something that is expected or realistically happens. Okay. It's a good goal to shoot for if that's your thing. See you in 2.5.